So good evening everyone. I think we will start today's session. So this is basically the 13th session that we are holding. So Thursday we had an extra class. So this is basically the 13th class that we are holding. So today mostly it will be revision. So last class also we did some assignment questions related to the initial topics that we had discussed, like some parts of thermodynamics and some part of the dynamics section. So last class we did that. So this class we will be continuing the same thing. So this class we will be covering mostly the ionosphere and the properties that we learned about the ionosphere, device shielding, plasma properties and everything. So this class will also be basically kind of a summary or revision. Okay, so let's start today's class. So yeah, so this one I thought like we will for revision we will try to solve the previous assignment questions. So basically in the ionospheric part. So this is from week 9. I have put the assignment questions and we will try to solve them. You have already done these questions, so I thought just for a revision it will be helpful. So the first question is, which one of the following is responsible for ions production in the ionosphere? So as we know, in the ionosphere, ions are basically produced by the incoming shortwave radiation. Incoming shortwave solar radiation produces ions in the ionosphere. So it could be X-rays, extreme ultraviolet, or ultraviolet. So in this case, the answer will be all of these. All these three could be responsible for the production of ions in the ionosphere. The second question, in the ionosphere, the order of peak electron density and the height from Earth's surface where peak electron density is found. So the question is where the peak production occurs, the peak and what is the peak electron density and what is the height of the peak production, Hm and Nm, the number density during the peak production. This is basically the question. So we have already learned, like in the ionosphere, the peak production occurs in the transition zone between F1 and F2. So basically it is a height of 250 kilometers and the peak electron density at this layer is basically 10 raised to 12 meter per meter cube. So in the ionosphere, the peak production occurs in the transition zone between the F1 and F2 layers. So if you guys remember F1 and F2, and they had diurnal variation based on the available solar radiation. F1 and F2 layer at 250 kilometer. So 250 will be either A or B, either A or C. And now the electron density or the concentration is basically 10 raised to 12 per meter cube at this layer. And raised to 12 per meter cube. So this will be the answer. A is the answer. Now, third question. Which of the following layers in the ionosphere is at night? So as I said, there are 4 layers in the ionosphere: D, E, F1 and F2. D, E, F1 and F2. So during daytime, all 4 layers are distinctly present because there is sufficient incoming solar radiation. Whereas during the nighttime, some of these layers disappear. So the question is, which of the following layers in the ionosphere? disappears at night time. So basically the D and F1 layers disappears during night. So this will be the answer. D and F1 layers disappears during night because of the unavailability of solar radiation. So the production will decrease. So basically these two layers disappear during night. Next question. Which of the following is the fastest chemical reaction occurring in the atmosphere? So like we had learned different type of reactions which helps in the production of ions and electrons in the atmosphere. So we have named them and we have learned reactions in the previous classes. So the question is which one of the following is the fastest chemical reaction that occurs in the atmosphere? So first one is radiative recombination, then dissociative recombination, then charge exchange, and then all of the above. So in case of dissociative recombination is in case of dissociative recombination, the recombination rate, which is alpha, is of the order of 10 raised to minus 13 meter cube per second. Whereas for all other recombinations, it is of the order of 10 raised to minus 18. For all other recombinations, it is of the order of 10 raised to minus 18 meter cube per second. So dissociative recombination is the answer. That is the fastest chemical reaction that occurs in the atmosphere. Next question is the reaction X plus, so this is basically H nu. The reaction X plus H nu is equal to X plus E minus is known as, where so the equation is basically X plus H nu is equal to X plus E minus, where X is an atom or molecule. So the atom or molecule is combining with a photon to produce an ion and an electron. So an atom or molecule is reacting with the photon to produce an ion and an electron. The reaction is basically known as photoionization. Photoionization is the answer. Next question. The term kT by mg has a dimension of K is equal. Okay. What is the dimension of the term kT by mg? kT by mg. So this is basically scale height of the atmosphere. So like the scale height that we have learned is basically H is equal to RT by G, where R is the specific gas constant. So as we have discussed before, this R is dependent on the type of the gas or molecule that we are considering. Basically depends on the constraint of the atmosphere. And we have another term R star, which is a universal gas constant. So the relation between R and R star is R is equal to R star by N, or molar mass, where M is the molar mass of the gas. And R star is universal gas constant. For 1 mole of any gas, this will be the gas constant. But in this case, in case of R, we are talking about 1 kilogram of a particular gas, which is dependent on the gas that we are considering. So R is equal to R star by N. So, and the Boltzmann constant K is basically R star by Na. So in case of one molecule, what will be the constant? That's what Boltzmann constant will say. So basically R can be written as K by M. So Boltzmann constant by M, R can be written as R is basically R star by Na into M. So R can be written R can be written as R star by Na into M. And K is basically R star by N. So we can, if we substitute the value of R over here, it will be K by, in terms of K, which will be KT by Mg. So the dimension of this equation, so the dimension of K is Joule per Kelvin, Joule per Kelvin by mass is kilogram, and this is meter per second square. Let's just Kelvin will be gone. Joule is basically energy, same dimension as force. So kilogram meter square per second square, right? Kilogram meter square per second square by kilogram meter per second square. Kilogram will go, it will be M. This is basically length. The scale height will have a dimension of. The scale height h in terms of r can be written as RT by G, and in case of the Boltzmann constant K can be written as h can be written as KT by N. Okay, where R is equal to K by N. Next question. Which of the following is or are the assumptions of Chapman's theory of layer production? So when we talked about Chapman's theory of layer production, there have been some assumptions that we made. So what are these assumptions applicable to the Chapman's theory of layer production? That is basically the question. So the first assumption is the atmosphere is isothermal and horizontally stratified. Yes, this is an assumption of the Chapman's theory. So only because the atmosphere is isothermal, in order to consider single scale height, we have assumed that the atmosphere is isothermal in Chapman's theory of layer production. And for simplicity, we have also considered the incident radiation is monochromatic and parallel. Monochromatic in the sense it has only one wave. So that also we have considered for simplicity. And then atmosphere is made up of only one gas constant. That also we have assumed, because like then only we can define a single cross section sigma, single cross section area sigma for all the gases. If there are different gases, then sigma will be different for different gases. So for simplicity, again we have considered that the atmosphere is made up of only one gas constant. So ultimately all three are true. So all of the above is the answer. Now this is a problem which is based on the recombination rate and time constant. Let's try to solve this. So the question is, if the recombination rate of a reaction is 10 raised to minus 8 centimeter cube per second. So alpha is given as 10 raised to minus 8 centimeter cube per second. Then calculate the value of time constant. So what else is given? Electron density Ne is also given as 10 raised to 12 meter cube per second. So if you guys remember, the time constant tau is given as alpha Ne the whole raised to minus 1. Recombination rate into number of into the number density inverse whole inverse. So alpha is 10 raised to minus 8. That is centimeter cube. So 10 raised to minus 2 the whole cube. Convert it into meter cube per second. 10 raised to minus 2 the whole cube into Ne is 10 raised to 12. So this will be 10 raised to 8. Yeah, can you mute yourself actually?
ஆரம்ப அப்படியே கொஞ்சம் கொஞ்சமா மெல்ல மெல்லமா அப்படியே கொஞ்சம் கொஞ்சமா ஏத்துவ பேச்ச.
Dilip, can you mute yourself? So it will be 10 raised to minus 8 into 10 raised to minus 6 into 10 raised to 12. This will give you an answer of 10 raised to 2 seconds, which is basically 100 seconds. So this will be the answer. So this was a question regarding the recombination to calculate the time constant. So the recombination rate and electron density was given. We just had to use the equation tau is equal to alpha Ne the whole raised to minus 1. So after substituting, it gave an answer of 100 seconds. The next question. Of the electron density of an ionospheric layer, Ne is given as 8.10 into 10 raised to 11 per meter cube, and the maximum frequency of radio wave which can be reflected back from this layer on vertical incidence will be. So this is basically on the critical frequency of an ionospheric layer. So we have talked about this before. Critical frequency is basically depends on the electron density of that particular layer. So only if the critical frequency is greater than only if the frequency of the radiation rate is greater than the critical frequency, it will be able to penetrate through the layer. Otherwise, it will be reflected back. So critical frequency Fc is given by root of 81 Ne. So in this case, the maximum critical frequency of the maximum frequency of the radio wave which will be reflected back from this layer. So if we if we reduce the frequency below this, then it will penetrate through the layer. 81 into Ne is given as 8.10 into 10 raised to 11, which is basically, so it will be 81 into 81 into 10 raised to 10. So it is basically 81 into 10 raised to 5, or 8.1 megahertz. This is the maximum frequency of the radio wave that will be reflected back from this layer. If F is greater than Hc, it will penetrate through the. The next question is, the height from the Earth's surface at which the air density becomes 1 by 100 times of density at Earth's surface is assumed scale height is equal to 7.5 km. So this thing we have been doing since the first class. So this is basically based on the vertical variation of density. So we have learned like the density of the pressure vertically varies in an exponential way. So P is given as P0 e raised to minus Z by H, where H is the scale height. We have also learned that the same thing is applicable for density. because T is equal to rho R T. So this equation particularly is applicable to an isothermal atmosphere, which means T is a constant. So T is also constant, R is already a constant. So P is equal to rho R. This means T is proportional to rho. So the same thing will be applicable to density as well. So rho is equal to rho 0 e raised to minus z by h. So here in this question, we have to find the height from Earth's surface at which the air density becomes 1 by 100 times of density at Earth's surface. So density at Earth's surface is basically rho 0. Density at Earth's surface. Can you please mute yourself? Density at Earth's surface is basically rho 0. The equation has told like rho is equal to rho 0 by 100 at z. At what height? At what height z, the density becomes the density at the Earth's surface by 100. So rho is equal to rho 0 by 100. So if we apply rho is equal to rho 0 e raised to minus z by h. H is already given, which is 7.5 into 10 raised to 3 meter. So rho can be substituted as rho 0 by 100 is equal to rho 0 e raised to minus z by h. So rho 0 and rho 0 will be gone. Just 1 by 100 is equal to e raised to minus z by h. So log of 100 will be z by h. To lose the negative sign, we will take this this will be 100 by 1. Instead of 1 by 100, it will be 100. So that we will lose the negative sign. So z will be h into 100. So 7.5 into 10 raised to 3 into log 100. This will be the height. So this will basically give you answer of 34.5 kilometer. This is the answer. So at a height of 34.5 kilometer, the density of the atmosphere becomes 1 by 100 times the density of the Earth. So we have just used the equation rho is equal to rho 0 e raised to h, where h by h, where h is the scale height. The same thing as given in the question. Okay. So now the next question. According to Chapman's theory for peak production, at any height, the production of number of molecules and cross-section area sigma should be. So this thing we have already learned when we were discussing the Chapman's theory. So Nm is the number of atoms or molecules present at a particular layer, Nm, and sigma is the area of cross-section of the number of molecules, activated number of atoms or molecules. So at so during peak production, the height at which peak production occurs, Nm sigma is equal to 1 and Nm is equal to sigma n. So this one we have already learned. So this will be the answer. Nm sigma is equal to 1. So the area of cross section of it will be equal actually. Nm and sigma. Whatever molecules or atoms are present in that layer, all will be activated. So sigma of all the atoms or molecules will be applicable at the will be activated at the peak production height. So that's why Nm sigma will be equal to 1. The next question. The height of the peak production in the atmosphere is independent of what? So we have already learned and derived the equation for the height of peak production. So which is basically Hm is equal to, so if you look at the electron density layer or Chapman's curve, so this is basically Hm. production rate, and h height. Based on the height, how the production is happening. So we have already learned h is equal to h log of a rho h c chi, where a is the cross section, is the scale height, chi is the solar zenith angle, hm is the height at which peak production is occurring. So in the question, the height of peak production in the ionosphere is independent of or doesn't depend on. It does depend on the scale height, we can see. It does depend on the solar zenith angle, which is chi, and it also depends on the cross section. And it doesn't depend on the incident radiation. The term I or I0 is not found in this equation. So basically, the intensity of the incoming solar radiation, the height at which peak production occurs is independent of the intensity of the incoming solar radiation. So incident radiation is answered. The next question. According to Chapman's theory, the height of peak production decreases as the solar zenith angle. So this thing also we have seen before. This is Q and this is H. This is HM. So this curve corresponds to the solar zenith angle 0, and as the solar zenith angle is increasing, let it be chi is equal to 40. So as the solar zenith angle is increasing, the height at which peak production is occurring is also increasing. So basically, as the height of peak production decreases as the solar zenith angle decreases. So when it comes from 30 to 0, the height at which, so in this case, this is the height at which peak production occurs, and at solar zenith angle is equal to 0, this is the height at which peak production occurs. So it is basically decreasing with a decrease in the solar zenith angle. So decreases is the answer. The next question. The bi-shielding will be perfect in the plasma if there will be. So the bi-shielding we have learned before, and a plasma, if we are introducing a charge, suppose charge Q, then the plasma will act in such a way that the effect of the this external charge will not be felt after a particular distance, which is known as the Debye length. So this phenomenon is basically known as Debye shielding. So in case of Debye shielding, it will be perfect if there will be very high temperature. So if there is very high temperature, the kinetic energy of the molecules will also be high, which means the thermal motions will be high. So in case of the thermal motions being higher, it will be very difficult for the electrons to create the shielding or to arrange around the charge just like this. The second one is if there is no electric potential. So basically, the device, a perfect arrangement like this is possible when there are no thermal collisions within the plasma. So that is the answer. When the thermal collisions are less, then the Debye shielding, whatever is occurring, will be perfect. That is the condition. The next question. The value of electric potential for the Debye sphere is given by. So the next question is the value of electric potential phi for the Debye sphere is given by. So this thing we have learned the equation, the potential at a distance r is given by 1 by 4 pi epsilon 0 q by f. Q is the charge that we are introducing. So this is basically due to the Coulombic force of attraction. function, and within a plasma, an additional term which is e exponential minus r by lambda d will also comes. So this is the additional term that comes due to the plasma. Like within the plasma, this so it kind of exponentially decreases. The potential that is felt will exponentially decrease as the distance from the charge is increasing. So that is not present in case of Coulombic potential. So that is the difference. So this is basically phi 0. So phi of r plus phi 0, which is the Coulombic potential, e raised to minus r by lambda d, where lambda d is the Debye. So the answer is phi of r is equal to phi 0 e raised to minus r by lambda. B will be the correct answer. Next is a numerical. So the question is, the scale height of a hydrogen atom at a temperature of 300 Kelvin will be. So basically we want to find the scale height of a hydrogen atom. Scale height is basically h, which is given by RT by G at a temperature of 300 Kelvin. So let's assume the atmosphere is isothermal so that we can use this equation for scale height. Let's assume atmosphere is isothermal, which means all along the atmosphere the value of T will be a constant. So the scale height is given by RT by mg. T we know is given as 300 Kelvin. G we know, which is 9.8 meter per second square. R we have to find. So R is basically, this is specific gas constant. So this is specific, this is particular for the gas that we are considering. So in this case, they have told the scale height of for hydrogen atom at a temperature of 300 Kelvin. So the atmosphere is constituting of only hydrogen atoms. So R can be computed as R star, which is the universal gas constant, divided by molar mass of the atmosphere or air. So 8.314 joule per Kelvin per mole by m, which is a molar mass. So in case of hydrogen, molar mass of hydrogen is 1 gram, which is 1 into 10 raised to minus 3 kg. This will give you a value of 8.314 into 10 raised to 3 kilogram per mole. Mole and mole will become joule per Kelvin kilogram. So this will be the value of R. 8.314 into 10 raised to 3 or 8314 joule per Kelvin per kilo. Joule per Kelvin. Yeah, that is the value of R. Now we can find H, which is the scale height. Scale height is given by R T by G, which will be 8314 into divided by 9.8. Can you try to solve this and tell me what is the answer? Yeah. Does anyone have an answer? So it will give you a value of 250. Yeah, please. Yeah, 254 point. Yeah, but yeah, 254.5 kilometers. This will be the scale height of the atmosphere if it only constituted of hydrogen. Okay, that's it. Now the next question. Question is the Debye length of the charge density is 10 raised to 12 per meter cube and kT is equal to 1.6 electron volt. So as I said, Debye length is basically the distance up to which the influence of the charge is present within a plasma. So the equation for lambda d, Debye length, is root of epsilon 0 kT by n0 e square, where epsilon 0 is 8.85 into 10 raised to minus 12 is a constant. KT is given as 1.6 electron volt, which is basically 1.6 into 1.6 into 10 raised to minus 19, and N0 is given as 10 raised to 12 per meter cube. Now, if we want to find Debye length, all values are given. Lambda d is equal to root of 0 E0 8.85 into 10 raised to minus 12 into 1.6 into 10 raised to minus 19. Sorry, it is 0.1 electron volt, not 1.6. 0.1 electron volt. 0. So it will be 1.6 into 10 raised to minus 19 into 0.1 divided by N0 is 10 raised to 12 into E. E is basically the charge of an electron, which is 1.6 into 10 raised to minus 19. So it will be 1.6 into 10 raised to minus 19, the whole square. So can you calculate and tell me what will be the answer? What will be the Debye length in this case? Did anyone got an answer? Okay. The answer will be 2.35 into 10 raised to minus 3 meter, or 0.235. 0.5 centimeter. So this will be the answer. Please try to work it out. So this root is applicable for both. This whole root of epsilon 0 kT by n0 e square. Where n0 is the electron density, T is the charge of the electron, and T is the temperature. So 23.5 centimeter or 2.35 into 10 raised to minus 3 meter will be the Debye length. Now the next question. In laser fusion, the core of a small pellet is compressed to a density of 1026 per meter cube at a temperature of 50 into 10 raised to 6 Kelvin or 50 million Kelvin. The number of particles in a Debye sphere in this plasma will be. So what all things are given? In a laser fusion, the core of a small pellet is compressed to a density of rho is given as 1000 per meter cube. It is basically the number n0. n0. N0 is given as 1026 per meter cube. Temperature is given as 50 into 10 raised to 6 Kelvin. We want to find the number of particles in a Debye sphere, which is 4 by 3 pi into lambda d cube. Within the Debye sphere, the number of particles we have to find. So here we know we have to find lambda d. Lambda d is not given. So lambda d can be found out with the same equation that we used just now. Root of epsilon 0 kt by n0 e square. T is given, n0 is also given. Epsilon 0 and k are constants. Where epsilon 0 is 8.85 into 10 raised to minus 12 and k is 1.38 into 10 raised to minus 23. Then T is 50 into 10 raised to 6 Kelvin. So if we substitute, it will become root of 8.85 into 10 raised to minus 12 into k, which is 1.38 into 10 raised to minus 23 into T is 50 into 10 raised to 6 divided by n0 is given as 1026 into electrons. Is 1.6 into 10 raised to minus 19 the whole square. So please tell me what you are getting. What will be the value of lambda d? Oh, okay, just a minute. It is 10 raised to 26, not 1026. Electron density is 10 raised to 26. It will be 10 raised to 26. N0 is 10 raised to 26. Sorry, it's not 1026. 10 raised to 26 per meter. Yeah, now please try to calculate it.
Four eight eight angstrom.
488 angstrom. Okay. Yeah, that's correct. That's 4.884 into 10 raised to minus 8 meter. In terms of meter, it will be 4.88 10 raised to minus 8 meter. So this is the value of lambda d. Now we want to calculate the number of particles right? So it will be 4 by 3 pi lambda d cube. So after substituting, it will be 4 by 3 into 3.14 into 4.884 into 10 raised to minus 8 the whole cube. How much it will be? The number of particles within the Debye sphere. It will be 4 into 3.14 into the Debye length the whole cube, which we just found out to be 4.884 into 10 raised to minus 8 cube. N0 into 10 raised to 26 are also there. 4.4 by 3 pi r cube, 4 by 3 pi lambda d cube into N0. 4 by 3 pi d cube into N0. How much it will be? It will be 4.88 into 10 raised to 4. I hope you got the answer. This will be the answer. So the question was to find the
Yes, ma'am.
oh yeah, thanks. The question was to find the number of particles within a Debye sphere. So the temperature was given and the number density was also given. So we had to find the Debye length with the given information, which is root of epsilon 0 kt by n0 e square. So initially we found what is the value of the Debye length, and then we substituted the value of Debye length in the equation for number of particles within the Debye sphere. So it is basically 4 by 3 pi lambda d cube into n0. So after substituting, we got an answer of 4.88 into 10 raised to 4. Okay. Now let's try to solve the assignment questions in the week 11. So yeah. So these are the questions in the week 11. Let's try to look at each of these questions. Okay, I think there is we will calculate this problem as well. Then we will move on to week 11. So the question is calculate the plasma frequency for electron of the electron density is 4 into 10 raised to 10 meter cube. So the plasma frequency omega was having an equation of 9 into root of n. So ne, this is a simple question. Ne is already given, which is 4 into 10 raised to 10 meter cube. So omega will be 9 into root of 10 raised to 10, 10 raised to 10, 10 raised to 10, which will be it will basically be 9 into 2 into 10 raised to 5, which is 18 into 10 raised to 5 hertz. Or a better way to represent it is 1.8 mega. This will be the answer. This will be the plasma frequency. Will be 4 density will be 4 into 10 raised to 10 meter cube. So that was the last question and assignments. Now we will see the assignment questions in week 10. Yeah. The first question is, when a particle with charge q and mass m is placed in a uniform static electric field, then particle's velocity linearly increases with respect to time. The total energy is conserved in this motion. Work done by electric field is zero in this motion, all of the above. So the question is, yeah. First assignment question is, when a particle with charge q and mass m is placed in a uniform static electric field E. We are placing a charge q in a uniform static electric field E. So let this be E will be acting in the Z direction. We are placing a charge q in the static electric field. So what will happen to the particle's velocity? How the particle's velocity will be varying? The first option was that the particle's velocity linearly increases with respect to time. So what will be the velocity of this particle? We have already derived. We are placing a charge in a uniform static electric field. The velocity of the particle will be in the same direction as the direction of the electric field. Vz0 plus q by m E set into t, where E set is the electric field. So it will be linearly increasing with respect to time along this z direction. In Vh sense, there won't be the velocities in the other direction will not be affected by the electric field. So this thing we have already learned. The second option was the total energy is conserved in this motion. So the first one was the particle's velocity increases with respect to time. So that is true. V set is a linear function of time. And then the second one was energy is conserved. Total energy is conserved in this motion. This is the second option. So, to prove this, we know F is given by Q into E, where E is the electric field. And if we write in terms of differential, m dV by dt is equal to Q into E. According to electromagnetic theory, del cross E, the curl of an electric field is 0, where E is basically minus del phi, which is the potential. So, m dV by dt can be written as Q into minus del phi. If we take a dot product of V on both sides, then it will become m dV by dt dot V is equal to Q into minus del phi dot V, which can be written as m into d by dt of half m v square is equal to so what we did mv dv by m into dv by dt is equal to q into minus del phi. Instead of e we substituted minus del phi and then we took a dot product of v on both sides of the equation. So m into dv by dt dot v is equal to q into minus del phi dot v. So this can be written in the form d by dt of half m v square is equal to q into del phi is dou phi by dou x I plus dou phi by dou ij plus dou phi by dou z dot v. V is vxi plus vyj plus vzj. In terms of the distance, we can write dou x by dou ti, is the differential of distance, and dou y by dou tj plus dou z by dou t into k. After taking the dot product, it will become minus q into d phi by d, which is dou phi by dou ti plus dou phi by dou tj plus dou phi by dou tk. It will become like this once you do the dot product. Dou x will be gone, so it will be dou phi by dou t. So minus q d phi by dt. If we take both on the left hand side, it will be d by dt of, so here it is d by dt of half mv square is equal to minus q d phi by dt. So if we take both on the left hand side, it will be d by dt of half mv square plus q d phi by dt is equal to 0, or half mv square plus d phi by dt is equal to 0. So this is the total energy, which is basically the kinetic energy plus the potential energy. So this is the total energy. So this is a constant. So this means the total energy is conserved. That is the third. That is the second option. And the third one was work done by electric field is 0 in this motion. Since the kinetic energy or the total energy is constant, total energy is constant. It means it means the work done, net work done will also be 0. Net work done is 0. Net work done will also be 0. Then, so third option is also correct. So basically, all three options are correct. So the answer will be all. So the first one, when a particle with charge q and mass m is placed in a uniform static electric field, we just found the particle's velocity linearly increases with respect to time. The particle's velocity is in the z direction, the same direction in which the electric field is acting. So in Vz, we found that Tz is equal to Vz0 plus q by m Ez into t, which is linearly increasing with t. The second one, we also found that total energy is conserved in this motion, and as a virtue of that, the net work done is also found to be 0. So the answer is basically fourth one, just all of the above. All three options are correct. Now the second question, which of the following is true? Magnetic field exerts force only on moving charges. Electric field exerts force only on stationary charges. Third one, magnetic field exerts force on charge moving parallel to the direction of magnetic field. And the fourth one, all of the above. So the question is, which of the following statement is true? First statement is magnetic field exerts force only on a moving charge. The force exerted by magnetic field is basically Q into V cross V. If V is equal to 0, it means F is equal to 0. So the first one is correct. Magnetic field exerts force only on moving charge, only on a moving charge. The second statement was electric field exerts only on stationary charge. Electric field exerts force on stationary charge, that is true, and it also exerts a force on a charge that is having a velocity v. So it is not only on stationary charge, it exerts force on stationary charge as well as a charge that is moving. So the second one is false. And the third one, magnetic field exerts force on charge moving parallel to the direction of the field. The direction at which magnetic field is magnetic field exerts force on charge moving parallel to the direction. Suppose consider that this is the direction of the magnetic field. So B is equal to dz. And the charge is also moving in this direction. B is equal to dz. So that's what it says. Magnetic field exerts force on a charge moving parallel to the direction of the field. If it is having the same direction, then F is equal to Q V cross B. So V and B are along K itself. So cross product will give you F is equal to 0. So the magnetic field doesn't exert force on a charge that is moving parallel to the direction of the field, which means the third one is wrong. So obviously fourth one is all of the above. That is also not right. So the answer is basically the first one. That is, the magnetic field exerts force only on a charge that is moving, which is having a velocity v. So for the second question, only the statement the magnetic field exerts force only on moving charge is true. All other statements are false. Okay, now the third question. A particle having mass m and charge q is at rest. Okay, on applying a uniform electric field on it, it starts moving. What is the when it travels a distance x in the direction of the force? So there is a charge q which is having a mass m third question. So there is a charge q which is entering charge q which was initially at rest, and on applying an electric field E, it started moving. What is the kinetic energy? So initially the force that was exerted on the object was F is equal to Q into E. Now the object, or the charge, sorry, not the object, the charge started moving. So the work done is given by force into displacement, which is x. So it is QE dot x. QEx. This is the force, this is the work done, or the kinetic energy when the charge starts moving. So the answer is QEx. So third question, the answer is QEx. And the particle having a mass m and charge q is at rest, once it starts moving, the kinetic energy that is experienced by the charge is QEx. That is the answer. Fourth one, if a particle of mass m and charge q enters in a homogeneous magnetic field with the velocity v is equal to vxi plus vyj plus vzk, then the trajectory of the particle in a homogeneous magnetic field will be. So this thing we have already learned. So there is a charge q which is having Just a second. Yeah. So this is the fourth question, right? Yeah. So the question is of a particle of mass m and charge q and thus a homogeneous magnetic field. So let us consider x, y, and z. The magnetic field is acting along this direction. B is equal to B. The magnetic field is acting along this direction. This field, a charge is entering with the velocity given by Vxi plus Vy plus Vz. Okay. What will be the trajectory of particle? So we have already done this. In this case, along the z direction, the particle will move linearly, and along the xy plane, it will have a circular motion. So basically, it will have a circular motion in the xy plane, whereas it will move linearly along the z axis. So it will have a helical trajectory. So in the presence of a homogeneous magnetic field, a charge which is entering will have a helical. A charge which is entering with a velocity v will have a helical trajectory. So in the xy plane, it will have circular motion, and then along the z direction, it will have that linear. So basically, it will be a helical trajectory. So that is the answer. So the fifth question is a numerical that we will do. Fifth, sixth, and seventh are numericals that we will do in the later section. Now we will finish the conceptual question. The eighth question is the term E by B has the dimension of what? What is the dimension of the term E by B? So if you guys remember, in case so the question is what is the this is basically the eighth question, I guess. So the question is what is the dimension of B? One way to do it is substitute the unit for E and B. And one easy way to remember, if you guys remember, when we learned how how a charge will behave in the presence of both electric and magnetic field, we found a term which is known as the drift velocity, which was having the same equation, which is basically E by B, or the same dimension. So drift velocity is basically E by B, which means this is having the dimension of velocity, which is meter per second. So the term E by B, which is basically the drift velocity of a charge which is entering a homogeneous electric and magnetic field. So E by B is basically having the dimension of velocity. That is the answer. So that is the easy way to do this, since it is, we know E by B is drift velocity, so it is basically having the dimension of velocity. Now the ninth question. The drift velocity of a charged particle in a uniform electric and magnetic field depends on. So just now we wrote the equation for drift velocity, which is E by B or E cross B by B. That is basically the equation for drift velocity. There is only electric and magnetic field present in the equation. E cross B by B square. Only electric and magnetic field is present. So then it doesn't depend on, basically from the equation we can say it doesn't depend on the charge of the particle, it doesn't depend on the mass of the particle, and it doesn't depend on the velocity of the particle either. So the answer is basically none of these. None of these parameters, the drift velocity depends on. It just depends on the uniform electric and magnetic field. So none of these is the answer. And now the final question. If RL is the radius of gyration of a particle in an inhomogeneous field, then the scale of inhomogeneity L should be. So till now we were discussing how a particle will behave in a uniform electric and magnetic field. Now this one was we have discussed in the presence of an inhomogeneous magnetic field how the particle will behave. So we introduced a term which is known as the scale of inhomogeneity for simplicity, and we said that the radius of gyration of the particle that we are considering should be very much less than the scale of inhomogeneity. So after the scale of till the scale of inhomogeneity that the magnetic field or electric field that we are considering will be homogeneous. After that only it will become inhomogeneous. So for simplicity we have assumed that the radius of gyration of a particle in an inhomogeneous field will be less than the length of inhomogeneity. So the answer is RL should be less than N. Second one is the right. Second option is the right answer. So RL is less than N. That is the right answer. Now let's move on to the numericals. 3 numericals are there. Now let's try to solve these. Yeah. So the first question is the radius of gyration of an electron of kinetic energy just a second. Yeah. So let's move on to the numericals. So the question is the radius of gyration of an electron of kinetic energy 10 mega electron volt and Earth's magnetic field 0.45 into 10 raised to minus 4 Tesla will be. So we basically want to find the radius of gyration RL. We have to find RL of an electron of kinetic energy 10 mega electron volt in Earth's magnetic field 0.45 into 10 raised to minus 4 Tesla. So the equation for RL is mv by qb. So we know m, which is the mass of an electron. So they have already told the particle is an electron. It is 10 raised to minus 31 kilogram. And q also we know, which is 1.6 into 10 raised to minus 19 coulomb. And b is given in the question, which is 0.45 into 10 raised to minus 4 Tesla. The only parameter that is missing is velocity. That is not given in the question. Instead, kinetic energy is given. So kinetic energy is basically half mv squared, which implies the velocity will be 2 into kinetic energy by m, root of 2 kinetic energy by m. So if we substitute, so here we know what is kinetic energy and we know what is m. So we can simply substitute V into R. So RL will become M into root of 2 kinetic energy by M divided by Q V. It will become root of 2 kinetic energy into M by Q V. Now we know the values of all parameters. So it will be root of 2 into kinetic energy is 10 mega electron volt, which will be 10 into 10 raised to 6 into electron volt. We want to convert it into joule. 1.6 into 10 raised to minus 9 divided by Q is again 1.6 into 10 raised to minus 90 into B, which is 0.45 into 10 raised to minus 4. So please calculate and tell me what will be the value. What will be the value of radius of gyration of the electron? Did anyone get an answer? It is 2 kinetic energy into m. So I have only multiplied with kinetic energy. It is 9.11 into 10 raised to minus 30. This mass term will also come. So what will be the value? Did anyone get? 2 into 10 into 10 raised to 6 into 1.6 into 10 raised to minus 19 into the mass of the electron, which is 9.11 into 10 raised to minus 31, the whole root divided by 1.6 into 10 raised to minus 19 into 0.45 into 10 raised to minus 4. Yeah. So the answer will be 237. This will be the value for the radius of gyration of an electron with kinetic energy 10 mega electron volt and the Earth's magnetic field 0.45 into 10 raised to minus 4 Tesla. This will be the answer. Please try to work it out. So the next question is the radius of gyration of an alpha particle and an electron of same velocity and a magnetic field of 0.01 Tesla will be what? So you basically have to find the ratio of radius of gyration of an alpha particle. So RL alpha by RL E. So RL is basically we just saw as MV by QV. So RL alpha will be M alpha. So they have given same velocity. The velocity is same by Q alpha and magnetic field is also same. So it will be B. And RL electron will be mass of electron into velocity by charge of electron into B. So RL alpha by RLE will be M alpha B by Q alpha B into B. Just take the reverse. QEV by MEV. So velocity and velocity are same, so it will be gone. B and B are same, that also will be gone. This will give you M alpha by ME into QE by Q alpha. The mass of the alpha particle is given. So M alpha is basically 4 into mass of electron. Is 4 into 9.11 into 10 raised to minus 31. Sorry, 4 into mass of proton, not electron. So M of alpha is given, which is 6.64 into 10 raised to minus 24 by mass of electron we know it is 9.11 into 10 raised to minus 31 into charge of electron the Q alpha is basically 2 into QE, 2 times the charge of an electron is the charge of an alpha particle. So we can simplify it like this. So it will be 6.64 into 10 raised to minus 24 by 2 into 9.11 into 10 raised to minus 31. How much it will be? This will give you an answer of 3644. So which basically means the radius of gyration of an electron is 3000 or nearly 4000 times. The radius of gyration of an alpha particle is nearly 4000 times the radius of gyration of an electron. So suppose if this is the radius of gyration of an alpha particle, RL alpha, the radius of gyration of an electron will be like this. The helical path that it will follow will be like this, RL. So that's what it basically means. So that's it. Next question. If the cyclotron angular frequency of an electron is 10 raised to 9 radian per second, then the value of magnetic field will be. So the cyclotron frequency is given, which is omega is equal to QB by M, where omega is equal to 10 raised to 9 radians per second. M is 9.11 into 10 raised to minus 31, and B we have to calculate. So B is basically omega into M by Q, which is 10 raised to 9 into B into M is 9.11 into 10 raised to minus 31 by Q. Q we already know is the charge of an electron, which is 1.6 into 10 raised to minus 90. So divided by 1.6 into 10 raised to minus 90. This will give you an answer of 'How much it will be? So it will basically give you an answer of 5.69 into 10 raised to minus 3 Pascal. This will be the answer. This is the value of the magnetic field. So that is the last problem. Yeah. So we just try to solve the previous assignment questions just as a revision. So I hope you guys remember. So just to conclude, we will just write the ins. So the Debye length, this is basically the length after which the influence of the electrons, influence of the charges in experience within the plasma. E, K, B, T, Y, N0 E square, where epsilon 0 E is having a value of 8.85 into 10 raised to minus 12. KB is having a value of 1.38 into 10 raised to minus 23 joule per Kelvin. Then T temperature. E is the charge of an electron. N0 is a number density. This is the equation for Debye. Now, if we want to find the number of particles within the Debye sphere, number of particles within Debye sphere, it will be equal to 4 by 3 pi lambda d cube into n. So this will be the number of particles within the Debye sphere. Now the plasma frequency omega is given by G 9 into root of n. This is the equation for plasma frequency. And the Debye potential is given by phi of r is equal to pi 0 e raised to minus r by lambda d, where phi 0 is a Coulombic potential, which is 1 by 4 pi epsilon 0 q by r. So this is the equation for Debye potential. Now when we consider peak production, this is Q and this is H. This is how it will look like. This is the height at which peak production occurs, HM. This is the value of H, which is QM. So as we said, as we saw in one of the questions, peak production height HM increases with the solar zenith angle height. If the solar zenith angle increases, it will be like the height at which peak production also will increase. And then the value for Qm is given as N0 I infinity cos pi by E. This is the equation for peak production. And then Hm, height at which peak production occurs, is given by H log of sigma H N0 C. This is the equation for height at which peak production occurs. So sigma is the area of cross section, and H is the scale height, and as we know, chi is the solar zenith. This is for Hm. Now the time constant tau is given by alpha Ne the whole raised to minus 1, where alpha is the recombination rate and Ne is the number. That's about peak production. Now, in the section particle nature of plasma, we learned how the particle will behave when we are in the presence of uniform electric field. We saw V set as equal to Vz0 plus Q by N E set in the T. So the velocity will linearly increase with respect to time, and we also saw that it won't be affected by the velocity parallel to the direction of the electric field will change. Vx and Vy will be the same. It is not altering the velocities along the x and y direction, in the perpendicular direction. Only V parallel is changing. Yeah. So this is the equation. Vx as Vx0 and Vy as Vy0. And in the presence of a magnetic field, we saw that the particle will have a helical trajectory. In the xy plane, it will have circular motion, and it will have a linear motion along the z direction. That was when it was in the presence of a uniform magnetic field. And when it was in the presence of both an electric and a magnetic field, and the radius of gyration of the circular motion, or the radius of gyration during the circular motion is given by RL is equal to Qn by plus basically mv by qb. Or in terms of kinetic energy, we found it as 2m kinetic energy by qb. This is the equation for the radius of gyration, and the angular frequency omega cyclotron frequency is given by qb by m, and fc given by 1 by 2 pi qb by is the angular frequency. The time period Tc is given by 2 pi m by qb. Now, how the particle will behave in the presence of both an electric and magnetic field also we saw. In the presence of both an electric and a magnetic field, there will be an additional velocity which is known as a drift velocity. It will be E cross B by V square. In the presence of both electric and magnetic field, a drift velocity will also come, which will be E cross V by V square. In the presence of both electric and magnetic field. Then we learned in the presence of an inhomogeneous magnetic field, there will be curvature drift due to the curvature of the magnetic field line, and there will also be gradient drift due to the inhomogeneity of the gradient in the magnetic field. Those things also we learned. That was in the last class. Okay. So that's the whole idea, like what all things we have covered and what all things we have learned. So I think I was able to cover most of the things. If you have any doubt, you can ask. Otherwise, let's end the session today. If you don't have any question, you can leave the class. So yeah, that's it for today. Thank you.